The only way to obtain exact metric dimensions of available vertical bone substance is by radiometric means. To circumvent the imprecise magnification factor of 1.2 to 1.4, radiographic examination is performed with a custom-made deep-drawn measuring template featuring metal balls. These metal balls are 5 mm in diameter and serve as reference in the X-ray. The sharp silhouette on the radiograph supplies the reference value for the magnification factor. In this way, the dimensions of available vertical bone can be evaluated very precisely using the formula 5 mm as the material diameter of the reference ball multiplied by the vertical distance of the alveolar ridge to the inferior alveolar nerve as reflected in the radiograph, divided by the diameter of the ball as reflected in the radiograph. In our specific example, this means 5 mm as the material diameter of the reference ball multiplied by 18 mm as the vertical distance obtained on the radiograph, divided by 6 mm as the radiographic diameter of the reference ball. Consequently, vertical bone distance is 15 mm. This calculated value should not, however, be understood as being equivalent to the length of the implant, since the tip of the drill exceeds the insertion depth of the implant by 0.4 mm. It is therefore necessary to keep a safety distance of 1 to 2 mm from anatomically critical structures like the maxillary sinus or the mandibular canal. Conventional radiographic techniques for metric determination of jaw width, such as side-view teleradiography, as shown here, are only useful in the center of the jaw. Hence, transversal bone availability has to be determined clinically by measuring the thickness of the oral and vestibular mucosa. The values obtained are then subtracted from the total width of the alveolar crest. The thickness of the mucosa is best measured in mucosal anesthesia using a dental probe with a movable silicone stop guide pushed over its tip. In this way, the alveolar process is sampled at several sites. The values obtained are transferred to a saw-cut model for bone mapping, which results in a rather faithful cross-section of jaw width. These data provide a good basis for anticipating the diameter and axis of the implant. Today, surgical procedures can also be planned via interactive software on the PC in the dental office. In this example, the planning was based on inserting hollow titanium cylinders according to the prosthodontic requirements into a thermoplastic template. These titanium cylinders will also serve as drilling aids offering axial guidance later on when the implantation is performed. The angle of the prosthodontically defined axial direction of the titanium cylinders can be corrected after CT analysis of the actual bone relations and realigned after thermoplastic softening. Now CT images of the patient are obtained with the planning template in situ. The CT data are converted via a computer center into a format that is compatible with the interactive software. The data are transferred via diskette or a high-speed data line to the PC in the dental office. The software represents the available bone substance in 3 different projections for further analysis. The right-hand side on the top shows the axial projection of the maxilla. On the bottom right side you can see the panoramic projection, and on the bottom left side you can see the various cross-sectionals of the maxilla. Now we will pick out these cross-sectionals that include the titanium cylinders and thus the planned implant sites. Section image number 12 shows a titanium cylinder over the alveolar crest in its correct axial direction. Well-structured additional measurements can be performed via the tool functions. Now, basic implant designs can be selected from a database and aligned in their definitive axial direction. Ideally, the implant axis coincides with the axis of the titanium cylinder. If the titanium cylinder is not correctly aligned, the angle at which it deviates is measured. In this way, the titanium cylinder can be adjusted in the planning template to its correct axial direction and can be used as a template for the surgical procedure. After positioning the implant body, the dimensions of the available bone are measured. The measuring tool is used to determine first the width of the alveolar process, which in our case is 8 mm, then the distance to the maxillary sinus, which is 14 mm, and finally the vertical distance to the nasal floor, which is 17 mm.